4.7 Spatial products of binomial. So last time when we talk about FOIL methods, um, when it comes to two term times two terms, FOIL method is actually considered as what we so-called the spatial products. Okay, so what is so-called the spatial products? It simply means these type of problem are designed for us to look at it and then write down the answer. Okay, so this very first one I want to introduce in this particular lecture video is called the difference of squares. So difference of squares says for any real number a plus b, well, you know what, let me do it right here. All right, if I have a plus b, two term times two term, but this time in the second parenthesis it's a same a same b, but the two parentheses, one is plus, one is minus. Okay, so the first term are the same in the parentheses, second term are the same in the parentheses. But when you got one plus sign and one minus sign, okay, that's called the difference of square. If we do a FOIL method right now, okay, I'm going to show you this thing will happen every time. If I do FOIL method, a times a is a squared, and then the outer is a times negative b, which is negative ab. The inner negative b times a, positive b times a is positive ab, because b times a is the same as a times b. And then the last thing I do is positive b times negative b. This is called a spatial product. Positive b times negative b is negative b squared. This is called a spatial product because when the first term are the same, second term are the same, one positive, one negative, the two term in the middle, the inner and outer, will always have opposite sign. Therefore, those two terms will always cancel out. Therefore, the answer will always look like my first term whole thing squared minus my second term b whole thing squared. The reason why we call this a difference of square, the difference means subtraction. Squares means it's a subtraction between two perfect square terms. Okay, so if we recognize that this our problem is a difference of square, we can simply just write down our answer directly every time. All right, so basically if we take a look at this example and think about the difference of square formula, a plus b times a minus b, my a is x, my b is 9, one positive, one negative. Okay, a are the same, b's are the same in the two parentheses. Then this is called the difference of square. Then the answer is always going to be my a, which is x, whole thing squared, minus the b, which is 9, whole thing squared. B squared, it will be 81. So that would be the answer. X squared minus 81. So this is like a little shortcut or spatial product, whatever you want to call it, because when you recognize difference of square, you can simply write down the answer without actually doing the FOIL method. Because whenever you do the FOIL method, the inner and the outer here in the middle will always cancel each other out. So your answer will always look like your a squared minus your b whole thing squared. All right, so let's try this one. Two term times two term. 5x, 1 and 1. One positive, one negative. So this is another difference of square. So my a got to be 5x. My b is 1. So my answer, I'm going to write this out real quick. My answer will be my a whole thing squared minus my b whole thing squared. A squared minus b squared. That's what my answer should look like. The reason why I'm writing this one out, all out is so we can see where the power rule that we learned in module 11.2 comes in. So here I got two different factors. 5 squared is 25. X squared is x squared. Minus 1 squared would just be 1. So my final answer will be 25x squared minus 1. All right. Now we have not run into two term times two term with two different variables. So we will do it right here. All right, a plus b times a minus b. So my a is 7x, my b is 4y. Okay, so the a's are the same, b's are the same, one positive, one negative in the parentheses. So this is another difference of square. So if I take my a whole thing squared, 7 squared is 49, x squared is x squared, minus, okay, my answer should always look like my a squared minus b squared. So let's see what my b squared going to be. 4y whole thing squared. 4 squared is 16, y squared is y squared. So my answer, 49x squared minus 16y squared. So if you fold this out, there's nothing wrong with fold them out, but it is always beneficial to recognize a difference of square problem whenever you see one. We do quite a bit of difference of square in Math 110 college algebra. All right. Now, let's see. This is the same thing. My a plus b. A and b are the same. A minus b. So this time, my a is x squared. My b is 4. So my answer should look like a squared minus b squared. So I'm going to write this one out too again. So if I take my a, which is x squared, whole thing squared, right? My a, let me write it down right here. So this is my a squared minus my b, which is 4, whole thing squared. Okay, that's my b. Let's see what happens. All right, my a, x squared, squared again, is going to be x to the 4th power, right? Multiply exponent, minus my b, which is 4, whole thing squared, which is 16. So this is actually considered as a difference of square answer too. Okay, very important that you see this because in module 13, here I will be asking you in reverse, which is, what was my a before it was ever squared? My a must be the x squared before it was ever squared. Okay, so when we do module 13, which is we're doing this backwards, which is actually which is called division, which is another word for factoring. Okay, that would be what we're going to do in module 13. Alrighty, so adding another spatial product called the difference of square along with our folio method. In the next lecture video, we'll take a look at something called the perfect square binomial, or textbook called them perfect square trinomial. All right, that will conclude this quick lecture video. Thank you for watching.